So guys, obviously I'm aware that what we've been doing is new. So like I'm not, too pushed at the minute, but what we've left is actually quite basic. So this is, I'm hoping that you don't struggle with this too much. Now, enlargements. For it to be an enlargement, they're actually similar as it is. So no matter what shape it is, if they say it's an enlargement, they're actually similar already. Now the centre of the enlargement is going to be the same all the time, and I want you to just get used to this. Now obviously I don't have graph paper here, so I've just made a sketch of the diagrams. But you always join the image of A back to A, and you keep going. The image of B back to B, and you keep going. And the image of C back to C, and you keep going. And lo and behold, what happens is they all join at one point, and that's what's called the centre of the enlargement. Okay, it'll be the same for the rest. Now, scale factor we've talked about already. Look for a corresponding side. 7.5 over 3. Right, which is 2.5. Find AB. Well, once we have the scale factor, everything opens up. So to get from here to here, we multiply by, and I think this was 4, I think I don't have it written in. But look, we don't know what that is. We don't need to know it. Don't forget the basics. This is a right angle triangle. So to find AB, we can use Pythagoras' theorem. So x squared is equal to 4 squared plus 3.5 squared. And that gives us x squared is equal to 16 plus, don't have my calculator on me, my phone is recording, but you get the gist of it, and what we end up with is that there, using Pythagoras' theorem. Once we have AB, we can find A dash B dash by multiplying by 2.5, which is the scale factor. And then they're looking for the angle A dash C dash B dash. Alright, now look, it's a right angle triangle, then they're looking for the areas. If it's a right angle triangle, how do we find the area? Half the base by the perpendicular height. Now, I want to show you something. First one is easy, look, there's the base, there's the height, or there's the base, there's the height. So for the small one, it's going to be a half, 4 times 3.5, which is 2 by 3.5, which is 7. I know the scale factor is 2.5, so automatically I know the area of the larger triangle is going to be 7 multiplied by 2.5 squared. Always the case. 7 multiplied by the scale factor squared. That will give you the area of the larger shape. And obviously if you want to find the area of the smaller shape, you just divide by the scale factor squared. So that was 6. 8. Now this brings in obviously a different shape. Now I won't be able to finish out the centre of the enlargement, but you'll get the gist. A to A, B back to B, C to C, we might be able to, and D to D. There's the centre of the enlargement. Right, straightforward. Scale factor. Two sides that are corresponding. I have 1.5 and I have 4.5. 4.5 over 1.5 gives me 3. There's the magic number. If I want to multiply, if I want to get the sides on this side, I multiply by 3. If I want to get the sides on this side, I divide by 3. If I want to get the area, I multiply by 3 squared. Find AD. Well, if this is 3, to work backwards, I divide by 3. Because 3 is the scale factor, that gives me 1. So that's 1 there. And then it wants me to find B dash, C dash. So if this is 3, to go the opposite way, so to go this way, I multiply by 3. To go that way, I divide by 3. Right? So it's going to be 3 multiplied by 3, which is 9 for that one there. Okay. Now, I'm not going to break this down. We should be able to find the area of these shapes. Look, it's a rectangle and a triangle. So look, just go across the middle there. So you have 1.5 times 1, I'll do the smaller one, gives me 1.5. And then remember, this is 1.5 as well. That's a right angle triangle. So half the base by the perpendicular height, half 1.5 by 3, that is 0.75 2.5 by 3, which is 2.25. If I want to find the area of the larger shape, I multiply by the scale factor squared. So 2.5 by 9 gives me the area of the larger shape. Now this one was obviously, they've tried to trick you a small bit by putting the shape inside it. Doesn't change. I'm going to do the centre of the enlargement first. A to A dash, B to B dash, and C to C dash. And we end up with a point somewhere there in the middle. I don't want to hide the fact that that's 8. Scale factor, we've 16 and 8. 16 over 8 gives me 2. Magic number, there's the scale factor. The area of ABC, if the bigger one is 96. So the bigger one is 96. Now remember, if I know the area of the smaller one, I multiply it by 2 squared to get the area of the bigger one. So if I want to go in reverse, so if I want to go big area to small area, I divide by 2 squared. So 96 divided by 2 squared, 96 divided by 4, that gives me 4 into 9 goes twice, and 16 left over, 24, and it's, I don't know if it's centimetres or metres squared anyway. Okay. AB, alright, I don't know, well, obviously if we know the area of this one is 24, the smaller one, how did we get that? Think, I don't have this here, so I can't use scale factor. So half 8 times some number x gives me 24. Half of 8 is 4. 4x is equal to 24. X has to be equal to 6. So you have to think, if you can't use scale factor, think what they're after giving us. They're after giving us the area of it. Don't forget that if it's a right angle triangle, you can still use Pythagoras' theorem, you can still use half the base by the perpendicular height, etc. Okay, centre of the enlargement is done. Finally, the last one. Obviously, they've tried to trick you here, and this is a small bit more difficult, but notice the way the enlargement is attached. So it's a small triangle, big triangle. The centre of this enlargement is actually O, because if you join D back to B, it ends up at O. C to A ends up at O. So the centre of the enlargement can actually, I know they don't ask for it in this, can actually be on the shape if you have two shapes inside one another. So what I've done is I've separated them out here. Now they're asking us for this one here, OA. You know that's 3. You know that's 7.5. So the good news is, now, this here is not 6. It's going to be x plus 6. So I've just given that a letter because I have to give it something if I'm going to go and solve it. Good news is here I do have the scale factor. Scale factor is 7.5 divided by 3, which gives me 2.5. And so I do know that if I multiply this by 2.5, I get this. So x times 2.5 gives me x plus 6. And lo and behold here now, what do you have? Because I've given it a letter in the first place, and I only have one unknown, I have a linear equation. 2.5x is equal to x plus 6. 2.5x minus 1x is equal to 6. 1.5x is equal to 6. X is equal to 6 divided by 1.5, which is 4. Okay, so that was a bit trickier because we had to give it an unknown. But just think, do we know the scale factor? That's the most important thing. 3 things to watch out for here. Centre the enlargement, be able to do it. Get the scale factor, that's the magic number. Right, you can figure everything out. Don't forget, if it's a right angle triangle, you can use Pythagoras or half the base by the perpendicular height. And the last thing is, the area increases by the scale factor squared. So if you want to work backwards, you divide by the scale factor squared. Okay.